time to do something about it. In this one, the bushing is missing. A bushing like this one. Yep. And here's what's left of the pin. Right. I brought all these little things here to the workshop because this is where the fun happens. And I also brought the smallest of the 3 buckets because the others 2 are too heavy to carry. And also this one needs some attention, as you can see. Now, let me show you the plan. A plan? That's new. I would like to change the system a little bit. Normally, this pin, and of course also the other one, goes in here, but the ears of this old bucket here are completely worn. Now this is the best one of the 3. So what I would like to do is to install a bushing welded on this side and one welded on this side, a bit this idea of course, but smaller. And then the pin can go through, and in the hole here I can put one of these clipses. A bit this idea. Doesn't work. I start from the idea that because I have to make new pins, because these, as you can see, won't work anymore. Because I have to make 2 new pins, I can make them as well a bit longer. So I need to make 2 of these 220 millimeters in a diameter of 30. I need to make 1 bushing like this one is right here, and 6 times a kind of shorter bushing that comes around here that I will weld on the ears of the bucket. And to make these new parts, I think I found exactly the material I need. Now this is a kind of shaft part of the thing, I suppose. And I will make new parts for another thing. The problem is, because this is too long to fit in my lathe in one piece, first I will cut some pieces. And it's also very heavy. Okay, Celtic, I have a little job for you. Right, here we go. This thing is now 47 and I need to bring it down to 30. So a way to go. Let's go for it. It's a 1.5 millimeter cut with a not too much feed. I will check number if you want. 0.16 per revolution, millimeter of course. And I hear the motor of the lathe stalling. So what's happening? I don't know. Let's take a file and see if this thing is hard. Nope, not at all. This thing is soft as butter. Of course, frozen butter. That was cut 1 millimeter. Let's see what happens. I can hear the motor of the lathe is really working hard. But this steel is not hard. So what's happening? I don't know. Is it maybe the beginning of the end of the electric motor on this thing? We'll see. Right, I will continue taking 1 millimeter cuts because it seems to work, and I will bring you back when it's a little bit smaller here. And this was the final pass. Right, let's get it out of here and take off this mushroom idea. First I will make the second one, and when that one is finished I will cut these big chamfers here to make it a bit tapered on both sides. Will be easier to install. Two. Now while I was cutting these things here I did a little bit of experimenting. A 1.5 millimeter cut when the diameter was as big as in the beginning was a bit too much because my lathe was running at slow speed. It's of course a 2-speed electric motor, but from the moment it became a tiny little bit smaller, I sped up the lathe in a second speed, a high-speed electric motor system, and I took 2 millimeter cuts and the lathe didn't even move. So it's I suppose the slow portion motor that doesn't work very well, but the high speed, good stuff. Right, let's make one bushing like this one. My first idea was to make this part without tail support, but I think there's too much stick out here. It's about 3 times the diameter and there is movement here in the bearings, so that's not gonna work. So I will center drill and then install the live center. And never mind this little spot here. This was a little bit of weld that I took off with a file. That's all. This was the end of my center drill. Why? That welding hard spot here, I don't think you can see it on camera, but it's here. It's deeper than I thought. Right, I will continue, bring it to outer diameter I need and see if this will be a problem or not. Right. You can hardly see it, but the tool can feel it very clearly. And it even chipped off a little bit the tip of my insert here. So I will other piece of material probably. That was an easy fix. All I did was cut a piece off and start again, and this steel is in very good condition. And now I am 40, spot on. Right, let's drill a hole and bore it out. Perfect. Except for the color, they look the same. I had to recut a tiny bit my inside bore on the new one, because I think what happened when I reinstalled it in the chuck, maybe it was getting a little bit deformed. A tiny bit. It did fit, but it was a too close fit, it was almost a press fit. So I did recut a tiny bit, and now, as you can see, it fits. Right, I think it's time to make these bushings here 6 times, but I'm gonna start with 2 because, as you can see, my part of something here is getting smaller. Outer diameter 45, and of course the bore of 30 because this pin has to fit in here, and a width of 18. Let's go for it. I would like to show you something. I just finished drilling this hole in this part, and because it's a big drill and I pushed a bit hard, the drill is grabbing. And in this kind of keyless chuck, the 3 jaws in there, they make spin the drill bit. So if the drill bit is tightening, spinning, it's gonna tight the chuck, and now by hand can get it out again. Now you can use, of course, all kind of hammers and crowbars and dynamite and welding parts on, and it's gonna make a terrible mess of your chuck. But I made this tool. Now this is the kind of tool you use to take out spark plugs in a car, for example. And I cut off the spark plug idea thing here, hex, and I kept the square. And this is just a piece of seat belt, of course, from the neighbor's car. Right, let me show you how it works. You take the loop, put it around here, on the knurl, give it a roll. Try to keep the tool on top, it's just easier. Take your socket handle thing here. Here you go. As you can see, my spark plug thing works very well, and because it's no steel on steel, of course it doesn't make a mess of the knurls here. So I think that's a win. And as you can see, I have another one, a longer one. Now, normally these things were made to take out oil filters and fuel filters in cars. Put the loop around the filter and then in some odd place, because here you have the engine block and on the other side there is the chassis, and here are cables for the starter or the dynamo or whatever, and there's never enough place to work. With this thing it's really easy. Let me show you. In the vise here is installed a piece of scaffold pipe, and scaffold pipe is slippery, right? Just like oil filters. Take my tool. I will take the long one because I take the long one, that's all. Now this one doesn't have a square, it's just a piece of pipe with two holes in here, that's all. Roller. Use my Allen key as a Tommy bar. Here we go. As you can see, the thing doesn't slip. These things work great. I have never seen anyone using the same kind of tools. Not in real life, not on YouTube, not nowhere. So maybe it could be that I invented something more than 40 years ago. But I just wanted to share to you, maybe you can use the idea. And while I was explaining all these very interesting things, my schizo myself finished these two rings. And as you can see, they fit very well. It's just that I didn't take into account that in fact I need 4 rings and not 2. Not thinking enough. Of course 4, because on this shaft I need 2 also. So all that's left to do for this bucket, and then of course for the others 2 also, is to make more of these rings, 2 for this one, and then make a little bit of taper on this side and drill a hole, and then of course clean up the ears of the bucket and clean it up a little bit this part here, because it's not gonna fit. And I think that will be for another video. End of the week again. Time flies, isn't it?